Okay, everybody. Hope everybody's doing good. So I just want to ask you right now before we get started, if you haven't subscribed and you're just relying on likes with the algorithm to keep sending you the videos, I'd appreciate it if you subscribe to the channel if you haven't done that. It helps me. I try to give out stuff all the time and try to be open to sources as much as possible. It hasn't really got me anywhere. Up until lately. I I'm getting at the age where I'm going to be thinking about retiring, and I'm not going to be able to do this stuff if I can't afford it. You know what I mean? I've spent a small fortune in investing in stuff over the years, and it's just endless. And it'd be nice to get support, and I do get some support, which is unbelievable. But I'd like to see more if I could. So if you like what you see, I've contemplated several times of just shutting my YouTube channel down, just shut it all down and just stay private. And because it hasn't got me anywhere to really make it worth my while. And I mean, I don't know who goes to work every day for nothing. So trying to take the time out to do it, and then you think, what am I doing? Why am I going to try and publicize it for? It's like um, I get nothing in return. And that's the way it's been over the years. So you gotta. I mean, there's people out there that are generous, and I've a lot of subscribers have sent me stuff, and I'm not talking about you guys or my Patreon members, because y'all in the category all by yourself. You know what I mean? You're doing what you can. I'm talking to the people that just want to just come in and see what they can get for free and move on. Some of those are trolls, but some are just running in either the channel or nobody is really interested in over Unity stuff or energy research. So that's the main problem. As I've put a couple of videos on my channel. That's one that shows a plastic water bottle chilling out, ice crystals starting after a jolt or an impact. Um, stupid number of hits in one day for that. And it's like it's what people want to see, I guess. Um, there's not many that are interested in this stuff. You got trolls and thieves, and you got legitimate subscribers that that are trying to do something on their own. Um, you got to think about me. I'm doing my own thing on my own, and I'm trying to share it with you guys. So um, there has to be a lot more support. Or in a couple of years when I go to retire, I'm not going to be able to retire. I'm going to have to keep working a part-time job just to pay for this stuff, and even that won't be enough. Um, yeah, I've got right now between magnets and other materials, and I mean the list is long. I could easily spend $5 grand right now, just a mouse click away, but I'm not doing it. So like, it's baby steps. Baby steps is never going to get us where we all need to be. Um, it is what it is, I suppose. All right, so this is my MIG testing board, and the collection coils that will be on this. Like hopefully next time you see it, I've got everything all wound on these, the trigger coils and the collection coils. Um, that's that I'm gonna have to do soon. I need to get that done. So, anyways, this block that you see right here, holding these capacitors down. I'm gonna do the same thing here, and then another one right here, just to hold them in place so they can't move. Um, I may sticky pad this stuff to the plywood for now. I may do that with everything right here. I need to have an aluminum with an L bracket on each end, or fold it over so that I can screw it in, but I need it to come up and over and back down and be fairly wide. I may even cut notches out with a Dremel to flush mount that right on the aluminum panel and go with a big piece in here. I need something to mount the toggle switches to. Um, and these toggle switches are used for swapping the polarity on the trigger coils, which will be wired through this DIN bar for easy connections. So power coming out of the MIG, raw power. Each cap is for each ring. So the rectified DC goes here. From here and from here is going to be combined. Each will have its own diode combined to another connection. Probably will bring it right in on this. And they'll come back out of that, run the wire down, and come into this. So these caps are going to run this buck boost, dropping it down, bucking down to 18 volts. Coming out of these caps, going to these caps, will be this buck boost. So this buck boost will be taking the power from this bank and driving this bank with a limit of 12.9 volts. These two signal generators are going to be powered by this small little 8 amp buck boost. And this cap is going to probably parallel up with the output of the buck boost to smoothen it out and keep everything rock solid. I don't want I want controlled voltage coming into the signal generators so that they act the same, regardless of what's going on with the system voltage. And then also another buck down. I think this is that's 400 watts. I think might be 400 watts. I'm not sure. With a potentiometer for current limit and voltage limit. I want to have those mounted on this aluminum plate that I plan on putting in here, because I want to be able to control drive current and drive voltage coming into the H bridges that you see sitting here. So that power coming out of this is going to go through this capacitor. This will be paralleled up with that to smoothen that out and keep it stable. So there's a few steps here, but I want 100% control over what it's costing me to drive this thing, to trigger it, and what I'm getting out of it. So ultimately, at the end, this will be the output that goes to, say, one of these. I picked up 4 of these on Amazon pretty cheap. So programmed really easy. So I could take that and use that to drive and charge a lithium bank, 200 amp hour lithium bank. I can use that eco-worthy charger to handle that coming out of here, and it'll take care of itself. It'll be all automatic, and there's BMSs in the batteries, so all that will do what it needs to do on its own. Yeah, to be able to control input voltage to these and current is going to be a nice thing to have. So this little one, I think that he'll handle. I think these will handle up to 30 volts. I may run them at like 14 or 12, somewhere in there. Actually, maybe even a little lower than that, because I don't want to overdrive these. So I might be right around 9 volts, 9 or 10 volts. This will be bucking down from the 18 volt capacitors, condensers. And this one here, I mean, I could be running these trigger coils at maybe 3 or 4 volts, at maybe 80 or 100 mils or less. Um, so I'll have control over that and what's coming into these H bridges and what's leaving. And being able to experiment with polarity swap on the trigger coils is a nice thing to be able to do that on the fly as well. Rather than shutting it off and moving wires around on the bin, it's just a flick of a switch over there, you know. So that'll be one polarity, and that'll be the other polarity. It'll be a quick way of finding out what's giving me the most output, using this as a meg rather than some kind of transformer action transferring from the trigger coil to the collection winding. Yeah, so ultimately this will be my output to do or go to whatever we want to run on there for a load. I'm going to show a real load on this thing running too. I want to know exactly what I'm getting out of this baby. But there's enough transitions and attenuation to the voltage steps, about as efficient as it's going to get. Using the buck boost. Am I wasting some energy here? Probably, maybe 15 or 20% right off the top. But it's minimized. And the real cost of triggering these, I'm going to find out when I get the turns ratio that I want for trigger coils. I could be 30, 40, 50 mils. So if I'm producing 5 amps out of this thing, if I get 5 or 10 or 15 amps out of this thing running, and it's only costing me 100 milliamps to drive it, that's insane. Absolutely insane. So high cope value, whether this is going to be, I don't know yet, but we're getting there. Real time, I could switch from volts to current and volts to amps and know what this thing is operating at, and the same goes with that one. So I've got, with the buck boost, built-in voltage monitoring and current monitoring. So that takes care of that problem. Regulating the power for the signal generators so that they're very stable, consistent output for a drive level for the H bridges, and then to be able to control what I'm actually sending to the H bridge for cost for triggering the meg. That is going to be ultimately very controllable. Yeah, so I got some work to do. Should be fun. Like to get it to the point where there's some results to show. Yeah, I'm gonna just take all these off and screw that right on there. I might even do it this way, on it that way. And this will be my buck boost junction from the 3 different cap levels. And these can be directly wired to the buck boost, so that don't matter. Got enough positive negative connections for every coil on here, from collection coils to trigger coils. Got them all right here. 2 seconds to run the jeweler screwdriver in there and move the screw and pull a wire out. Do whatever you want. It's going to be easy and convenient. And then also, I may put in another row, excuse me, another row of double pole, double throw toggles. I'll want to switch in a capacitor bank for the collection coils and resonating them. So that'll be nice to switch that in and have the capacitors out here so that I can switch off and find the right value that I need for resonating the output coils, because I definitely want to do that. By doing that, you're creating a ring and also allowing the whole thing to kick back, so your cost is going to be less. Check out the Patreon. This video is going to be probably the only one that's going to show up on YouTube of this. I will do a sneak peek of it up and running, but the long versions of video footage of everything that you're going to see on YouTube is over at my Patreon. So the ones that are really interested and are willing to pay to get all the critical information so they can start their own duplication, you know. That's what we're after. So, okay. Appreciate y'all. Talk soon. See you in the next one.